Actually. Alexi, thank you so much. Nitro, thank you for hosting us. I'm really excited to be here to talk to you guys today about Scala Notebook, ! So my name is Chris Yang. I used to work at Bridgewater Associates a couple years ago. And Scala Notebook was a project that I worked on there, sort of a skunkworks thing, and they decided to open source it a little bit. They decided to open source it, and we've been contributing sort of to it every once in a while. After leaving Bridgewater, Nick and I started a company called Domino Data Labs. Hopefully, Nick will do a demo about that after. But this talk is going to be 100% about Scala Notebook, basically. So what is Scala Notebook? Scala Notebook, highest level, it's a browser-based REPL for Scala. So it's written in Scala, and it's for running Scala code. And if you're not familiar with the notebook format, you should think of like IPython notebook or Mathematica. But the idea here is that in a notebook format, you can interleave code, text, graphics to make a rich document that you can sort of read top to bottom. And so this is especially useful for data analysis, data science, scientific sort of workflows, as evidenced by sort of the success of Mathematica and IPython notebook. But actually, in the course of developing Scala Notebook, we've sort of just figured out having a really powerful REPL that can render things in HTML is actually just sort of generically useful. And one of the goals for Scala Notebook that we were interested in originally at Bridgewater was sort of multi-tenant hosting. So the idea is that we could have one Scala server and that people internally could have their own Scala sessions going at the same time. Whereas I think in IPython Notebook now, it tends to be more of a developer local type stack. So there are some architectural security concern implications of that. So demo time. And so basically, this is going to be sort of a, what was this? Oh, gosh, OK. So this is a Scala Notebook. Hold on. This is a Scala Notebook. So you can sort of tell that it's basically a sequence of cells. And cells can be sort of one of two types. They can either be text, like documentation. And so in this first cell, you can tell this is just a markdown formatted cell. We can add another, move a hash, hit enter. The title becomes bigger. But more often than not, your cells are going to be code. And so here, we hit Control Enter. And what that's doing is evaluating this expression in what's called the kernel, which is basically the Scala backend where this user code is running. And so the code is here. We capture the standard out, and then some representation of the Scala object is returned back. And so you can do sort of normal REPL-ish things. You can define a method there. Then you can call it sort of basic stuff. And sort of by convention, notebooks execute top to bottom. And so you define fact before you can use it here. But actually, you can sort of run the cells in any order. It's useful in like an iterative context where you're sort of figuring out what's going on in one cell as you're trying to figure out a function or something. Just a couple nice things. If you try and evaluate an expression that doesn't compile, then the Scala Notebook will just give you a line number and say, hey, this doesn't compile. And similarly, if you are running code that throws an exception, so this calls sys.error, gives you the stack trace back. And so just not super sexy stuff, but what you actually need to actually write code in this environment. Scala Notebook handles HTML natively. And so here you can see we're generating an actual HTML table with 5 rows, 4 columns, and each cell is going to be the product of the row and column index. So you can see here. And then it also handles images. So for example, here is a GIF of a cat. One subtle thing, which isn't obvious from the examples that I've showed before, is that we stream the standard out as the cell is executing. And so what's happening here is that we're going to loop 1 to 10. We're going to sleep half a second. We're going to print the number. And so what's nice about this is that if you have a particularly long-running cell, you actually get some feedback into what's going on before the code actually returns. And so we'll go a little bit more into detail about that later. But so you can see here, we got the standard out even before it returned, but once it returned, then we got what we had expected. And the last thing in that vein is each notebook is configurable to have a startup script that will execute whenever the notebook is opened. And so for example here, this widgets package object is actually available to your code inside this notebook by merit of an inits.sc file that imports that package object, basically. So sort of like a bash RC, but for Scala notebooks, and that's sort of configurable as well. OK. I'm still getting mixed up as to where my cursor is. OK. So I want to talk a little bit about the architecture sort of backing everything that you just saw. So the first thing to just remind you guys, a kernel is the term for the backend where the code is actually running. It's stateful, obviously, as you're defining new classes, new imports and stuff. So obviously, the result of what you run after depends on what came before it. And there's one kernel per running notebook session. And so potentially, there are many kernels per notebook, because one person could have the notebook open several times. You might need to restart the kernel if you're modifying something like the class path or the initialization script. And then because many users can be running their own Scala notebooks across the same server, so you sort of multiply that out, and potentially there are many kernels being managed by one Scala notebook instance. Does my cursor work? You guys can see the cursor, right? All right. So the front end, I think I mentioned this, but just to say it again, we forked IPython Notebook and basically replaced the Python backend with Scala. But the front end, all the JavaScript, is basically all there verbatim with like very, very few changes other than the CSS styling that you saw. And so the relevant bit here is that in JavaScript, there's a code cell object. Like I said, not really touched from IPython Notebook. That communicates to the Scala Notebook server over 3 sort of open WebSocket connections. There is oh, I'm sorry. Let me come back here. The calc WebSocket service. Oh, is there actually a laser pointer? This might be. I'm going to like blind someone. Is this a? Oh, yeah, awesome. So the calc WebSocket service basically knows how to map an open WebSocket connection to a running kernel. And the kernel over here, we basically use remote actors to communicate between the server and the sort of front end, the like API of this kernel, which is a REPL calculator, which is itself an actor. It has a handle to our REPL service, which itself is implemented by using the Scala imain class, which is the like built-in interpreter that backs the actual Scala REPL. So the basic API is pretty straightforward. Whenever the user wants to run code, they issue an execute request that goes from JavaScript all the way to the kernel via WebSocket to act a message to essentially a REPL function call. The kernel can pass 3 messages back to the front end. So first message it can send back is whenever there's a println from the running kernel, from the running REPL evaluation, it can send a stream response back. Once the interpretation of that line of code finishes, you can either return an execute response or an error response. So an execute response is basically, hey, this completed successfully. Here's the HTML you should stick back in the notebook. If it failed, we distinguish between compilation errors or sort of like runtime exceptions, and then we'll either pass a stack trace or the compile error there. Let's see. So this is the API of sort of the REPL service here. There's a couple things that we'll get into later in the presentation, but the fundamental one is probably what you'd expect, which is, hey, evaluate this code, and then we have this little functor that allows us to do the like println streaming back. and it returns an evaluation result, and this string is basically the fully written out, fully flushed standard out. The evaluation result is either incomplete, which means a compile failure. Failure here is a runtime exception, and success is, hey, this completed, and here's how I want you to render it. We'll come back to why this is a node seek rather than maybe what you think would just be like a string or something. We'll talk about that more when we talk about how the rendering works in Scala Notebook. Just to summarize this, this was an enormous pain in the ass. IMain in Scala library is not designed to do this. It was a real mess. And so most of the effort of getting this to work was sort of reverse engineering how IMain worked. And I think there are some improvements slotted at some point in the future. And evaluation was definitely easier than some of the completion stuff, but it was still a mess. And at the end of the day, this is a pretty simple API, and I wonder if there are other better REPL-y services out there. We thought there would be a lot of juice out of using the IMain, but it's totally conceivable there's a better way to implement this sort of trait. One thing that may have been a little subtle that you guys may have missed is that the kernel where the Scala code is actually running is actually a child process, like a child operating system process. And that was basically because we needed to support this multi-tenancy use case. Potentially our users have different security levels, have different level of access, are permissioned to different pieces of data, and so you don't want an attack where, because they're just running code, right, like arbitrary code, so you don't want them crawling the file system trying to eavesdrop on other running Scala Notebook sessions. And so I think something that could be cool is that those kernels could potentially run on a different machine entirely, perhaps inside a Docker container to achieve even more isolation. There are a couple second order reasons why we did it beyond sort of the multi-tenancy. The first one is that each kernel potentially needs its own class path. And so it would just be quite tricky to, inside one VM, sort of properly manage the class path of the sort of this child REPL. And then the other thing is that it's quite easy to accidentally write something that could totally blow up in terms of like an infinite loop. And so you need a really reliable way of stopping these kernels and restarting them. And killing threads in Java is not easy. Really, the most reliable thing you can do is just, OS kill that process and do it that way. So this wasn't without cost. There's quite a lot of shenanigans inside the REPL spawner code that spawns the VM with the right remote actor, with the right remote settings, and there's some bootstrapping to get that inter-process communication to work. But I think overall it was the right decision, but that part of the code could definitely be cleaned up and made a lot more reliable. The nice thing about having it be a process is that stuff like memory leaks, at the end of the day, you could just blow up the process and restart the kernel. It wasn't that painful, and so it just gave us a lot of outs. OK, we got the basics out of the way. The interactive widgets are pretty cool, and so we're going to do a live demo of that. Let's see. Go over here. Let's close this one. OK. Everyone see this? Yeah, that's probably better. OK, so one of the things that was important to us as we were developing this wasn't just the ability to run Scala code interactively, but we were particularly interested in building things like dashboards, so that, and in particular, what you need in that is the ability to interact with the notebook as like almost like a web page itself, so like sort of tweak HTML elements and have that do stuff in Scala, basically. And so we're going to just go through a couple of these widgets that we created as samples. So a widget in Scala Notebook is basically interactive HTML whose values can be triggered by things happening in Scala. And so one of the widgets that we have in the box, right out of the box, is an input box. And what that does is create an input text box. And so one of the things we can do is we can have the value of this text box be triggered by a Scala expression. So in particular here, we're going to take a random alphanumeric stream. We're going to map it to string. We're going to take the first 10. And then this observable.timer basically says, I'm going to take a new element every 50 milliseconds. I think that's what this magic 5 means. That observable, then, we can bind to the current value of this box. And so after this runs, then hopefully, you can see here. So this is eventing from Scala inside the running kernel all the way back to the front end. So that's not all. So we sort of need bidirectional communication. That's important for being able to actuate stuff on the page. And so we're going to define a second input box here. And then we're going to say that the value of the first input box should always be the same as the value of the second input box. And so I'm going to run this. I'm going to come here. We're going to do hello. And so we'll go deeper into the mechanics of how this is working. But essentially, I can type here, and that'll get mirrored up here. We can do more advanced stuff, too. It wouldn't be particularly interesting if we just wanted mirrored text boxes. So what we can actually do is hook up the value of the second text box, map it through some transformation. So in this case, I want to take the current value of IB2, the second text box, and I want to convert it to uppercase. And I want that uppercase version of the value in the second text box to be reflected in the first one. Sometimes it's a little finicky, so I don't know if this is going to work otherwise. There we go. Yeah, all right. And so, we can do sort of simple transformations that way. Just to illustrate the point further, we can, there's a drop-down widget. It's seeded with 3 choices. So we can see A, B, and C. But the dropdown has 2 sort of actionable surfaces. One of them is the selected value, but the other one is the set of options that are part of it. And so we can say here that we want the list of options of this dropdown to be the current value of the second text box, but we want to split that by commas. And so, oops. Say USA, China, Japan. Oh, I didn't actually run the thing, sorry. And so we change that up here. Then this has been changed to do that. Come back here, add another option. We've added this new option here. And so I think the other thing worth noticing is that the connection to the first input box is still there. And so it's still capitalizing the strings. And so widgets can sort of, there's an end-to-end relationship between their connections. So let's come back to talking about how this actually works. So the picture we had earlier is not complete. So in addition to the code cell, calc WebSocket service, REPL calculator, REPL, there's this parallel observable path that's sort of analogous. So at its core, we're using sort of functional reactive programming on the Scala side. We're using sort of the reactive equivalent inside the JavaScript. So we're using Knockout. We're using the Knockout.js observable, and we're using the reactive Java observable method objects over here inside on the Scala side. And so basically, all of this cruft in the middle is basically trying to marry up a Knockout observable in the JavaScript with a reactive Java observable in the Scala. And so right now, there are only relationships between the Scala side of things. there isn't a way to say, hey, I want this JavaScript observable to be directly linked to another JavaScript observable. And we thought about that. You definitely pay a latency thing, especially if you're trying to do something simple, like just mirror two text boxes, because you have to wait for an entire round trip for that change to get propagated on the Scala side. But ultimately, people were interested in writing Scala code, and so I think that was the right decision for that. So I want to trace through literally what's happening in that text box example. So if you'll remember, basically, what we want is to be able to type a lowercase string over here in this first text box, and then have the uppercase version set up over here. So first thing that happens is that the user clicks inside the input box and literally types words. And so by merit of the way that the knockout stuff is set up, knockout basically takes care of if the user touches the DOM, how that gets propagated back as a change to the underlying knockout observable. And so when I type hello world here, let's just call this observable 1111, observable 1, gets assigned a new value, hello world. We wire up the knockout eventing such that whenever there's a DOM change, whenever there's a value change here, we know to send an event to the observable WebSocket service saying, hey, observable 1 got a new value, so you should be aware of it. So this layer is inside the server. The observable WebSocket service knows how to map an observable with a particular ID to a particular running kernel. It transforms this request into an equivalent ACA message, and then that message is fired to this JS bus, which is a remote actor, and it's also a singleton. And this singleton keeps a map of, for a given ID, observable 1, what's the actual underlying reactive Java observable. And so when it gets this message, hello world, it goes and looks up the observable and calls onNext on it, which is basically the, hey, here's a new value for this observable. Because we've run this map subscribe earlier in the code, then when observable 1 value gets changed, then it automatically runs to uppercase. That tweaks observable 2's value. JS bus knows to listen to changes to observables registered to it. And so when that happens, when it detects that happening, it says, hey, JavaScript, observable 2 has a new value. Here it is. That gets routed all the way back through. Knockout gets that setting to hello world, and the knockout is actually what replaces the DOM element in the HTML. And so it's that's a lot of hops, basically. Let's see. Let's go here. So how do you write one of these things? The API isn't great, but I do want to walk you through it. And sort of at the crux of it is basically there's some juggling of when stuff happens in JavaScript and how stuff happens in Scala. But really the name of the game is that observable ID on the previous slide of observable 111 or observable 222. That string needs to get passed from the back end all the way to the front end, and sort of those objects need to get created at the same time. So this is the actual code for the actual input box. It extends widget. Widget's interface is basically, hey, if I call to HTML, you'll give me back HTML. First thing that happens in input box is we use the JavaScript bus singleton to create a connection. And a connection is basically the pair of the observable and the observer. And so this is the thing that knows how to map a JavaScript event to a Scala observable and vice versa. And so the input box defines a public value called current value. That's basically a function of that underlying JavaScript connection object. And what's subtle here, and you'll see this codec thing here, is that you really want the type of this current value to be something Scala-ish, like a string in the case of an input box, and that's sort of like a trivial transformation. But you can imagine for the drop-down box, you want like an index, or potentially even something like higher in the abstraction, like a country. Like if you had a list of countries, you might want that drop-down's current selected value to not just be a string, but to be the actual country. So what the JS bus creates when you create a connection there is something that speaks JSON. And so this codec, this bimap codec, is basically the thing that tells you how to convert from the JSON value to the Scala-specific type. So here's where the real dance is, basically. So this to.html, we create the outer input DOM. And then we call scope script. And then this JavaScript gets executed before the HTML gets inserted. And this is the thing that sets up the knockout bindings. And so here, scope script basically lets you, so when you create a JavaScript JS bus connection that comes with an ID, that's the obs111 in the previous example. And then we basically pass that into the JavaScript via this like map. And then so value ID is the name of the JavaScript variable where this string is bound. And we use that to create the JavaScript observable here. So that's how those two things get married up. And so there's a bit of nonsense here inside scope eval, which is the actual thing that evaluates this JavaScript to set that up such that this method can look the way it looks. And the other bit of trickery is that this binding inside the JavaScript is bound to this DOM element out here. So you can see here, scope is this dot parent element. This, in this case, is this bit of JavaScript. And then we call it with the scope. And to be honest, this is extremely confusing. And I don't entirely remember why we implemented it this way. I think there was some value in having this thing look beautiful at the price of traceability. Like, this is basically a nightmare to figure out. If you get this wrong somehow, then it's basically a nightmare to figure out how this actually works. OK, let's talk about rendering. And so this is something that I highlighted earlier in the demo, but is actually a little bit subtle. So Scala Notebook, by default, has a bunch of helpful renderers. And a renderer, in this case, is basically a thing that can take an arbitrary Scala object, in this case a seek, and turn it into something HTML-ish. And so by default, there's a seek renderer that turns a seek into, takes the first 25 elements of a seek and turns it into a table. But sometimes you want more granular control. And so we give you the ability to define your own renderers. And these can be things either defined in a custom class path or in the init script, or even just sort of here in the notebook as you're trying to develop it. So what if we wanted to render seeks of ints not as a table, but as a comma delimited string? And so what we've defined here is a renderer. It knows how to take a seek of int. And we create a text element. We take the first 25 elements. We call make string on it. And so in this case, 1 to 100 actually gets rendered as 1, 2, 3, 4, 5, 6, et cetera. Another useful example is rendering products, so case classes and tuples. And so in this case, we want to make a row of all the values of the fields of that product. And so we'll define this renderer. And then we're going to define a new case class, foo. It has 2 elements in it. And so that gets shown as a row, like a JavaScript, as an HTML table. What's cool about this is that we'll talk more about the typing and how Scala Notebooks knows which renderer to use. But in this case, we can say, well, I actually want to render seeks of products as a table so that you can sort of easily visually compare all the elements of the same in the same column. So we hit enter here. And then here, we'll see a table where each row corresponds to an element, and each column corresponds to a single field. So this is sort of the value of A, and this is the value of the second parameter. So this is the main renderer API interface that you need to implement. It's pretty straightforward. Earlier, I highlighted why the result of successfully computing a REPL is not a string or an any, any ref, but actually a node seek. And the reason for that is that the actual rendering code happens inside the kernel. And if you sort of squint at that for a second, you'll realize that that's the only answer that makes sense. The renderer couldn't help but run anywhere else. And so the rendering code actually happens inside the REPL as part of this evaluation loop, and that's why the result is a node seek, because that's that's our representation of the HTML. Let's skip that a little bit. So how does this actually work? So I don't know if any of you guys have ever sort of dug into how the REPL works, but this is a type of code that it generates. Basically, it defines a new object for each line that's evaluated, and then there's a set of imports that give you be able to access previous results. And so what we do in getting the rendering to work is that we'll ask the REPL to evaluate the original request. That'll get assigned to a value like res1. And then what we do is we code gen this new object and tell it to call rendered. And so what's happening here is that rendered is explicitly set as a type of widget. Res1 could be anything, because you were just running it, and sort of could be anything. And so the magic here is that we actually use an implicit def from renderer to go from this type A to an actual widget. And so these are all the implicit objects, implicit renderers that are defined in Scala Notebook. There's one for HTML, there's one for node seeks, there's one for strings, there's another one for seeks. And so basically we use the implicit conversion type resolution of the compiler to actually figure out which renderer to use. And so this obeys all of the standard scoping rules of implicit resolutions. I guess the semantics might be changing soon, but for now, this means that an implicit def that you have, an implicit renderer that you have sort of defined later on will take precedence over an implicit renderer that you defined earlier, which is the behavior that you want. Because if you're like trying to iterate on a renderer and make it work, you want the latest version of that renderer to actually be the one that's used. OK, last demo. So I want to talk a little bit about completions. And this is one of those things that's not so sexy until you actually have to use this, and then you sort of start missing the fact that you can hit control space in IntelliJ, and it tells you what to do. And so the good thing about Scala Notebook is we've wired, so I'm going to hit tab here. And then you see there that it auto-completed to Notebook. And then we hit tab again. And then this gives sort of the set of choices here that are completable. And so what this is doing, it's not anything fancy. It's just wiring into the underlying REPL completion. Similarly, we can hit left paren. And then this hooks into the double tab behavior in the REPL to give you the actual function definition. It also works for, oh gosh, this is tricky. It also works for overloaded methods. So here are the two printlns. And something that we added to Scala Notebook that has an equivalent in IPython Notebook, but doesn't have equivalent in the REPL, is we complete string literals. And so here, I've opened a string literal, I've typed the letter S, and I can hit tab. And so what this is showing me isn't code completion, but it's actually listing all the files in my working directory and giving me a little bit of metadata around it. And so we originally wanted this functionality because we wanted to autocomplete on things like column names on a SQL table, things where there wasn't, the type system wouldn't help you because we didn't want to define a new type for every SQL column. And so this is an example. And there's some nice metadata. So for example, if we detect it's a directory, we tell you. If it's a file, we give you the size. But you can sort of imagine this being sort of generically flexible for auto-completing all sorts of stuff that you want to complete. So I just want to go through this stuff quickly. Basically, these are the other sort of two methods on the REPL interface. So for example, in that first example, we had com.bwater.notes. You hit tab, that calls complete, and that gives you basically, hey, notebook is the only completion. And then similarly with after the dot, you get a list of these things, and the IPython front end basically knows how to render that. Similarly with the string completer, this is the string literal completer with the file names. It's a very similar API. You tell me what to complete, and I'll give you some matches. What's not shown here is that this match object actually has a arbitrary metadata map, so that's how we're passing back the absolute path and the file sizes in there. Object info is a similar thing here. So sys.error, you get back def error message string, nothing, you get the signature back. It would be really cool if we could inspect the object statically, if we could hook into some Scala doc stuff, but there wasn't a great way to do that at the time. A brief aside on the completion code. I mean, the code is littered with comments like, turns out this is really important, but we could not remember for the life of us why that needed to be false. There were comments saying, just trust me, or go read this other line of code and all will be clear. When you went to read the other line of code, the very first sentence was, this gets a little bit hairy. And so this all just connects back to the iMain was not at all designed to be like an interface for doing this type of inspection of the running code. So a lot of reverse engineering went into this. I think we briefly looked at IntelliJ's open source syntax tree parser. And there were some rumblings that SBT was exposing some hook to like give you this type of completion. Yeah, if anyone knows what the state of the art is now in terms of doing this programmatically, I'd love to know. So I think Nick, hopefully, will be talking a little bit about the project, the company that we've started since leaving Bridgewater. So he'll go into a lot more detail. I think the thing to say about it now is, Domino is a platform to help analytical workflows, help data scientists. But in particular, we've actually integrated Scala Notebook. And so let's see if I can find it. And so we've actually made a public Domino project that lets you, with one click, spin up a Scala Notebook session. So hopefully that's something you guys can check out and play with it. And one of the cool things about Domino is that we make it really easy to scale hardware. And so if you wanted a Scala Notebook session, but you wanted to run it on a monstrous machine here, maybe this isn't so monstrous, but it goes up from there. With one click, you can click, hey, I want to switch hardware, go back here, start a new session, and then all of a sudden you're running this interactive Scala session, but on a very big machine. So more useful if you're doing analytical type stuff. I realize now I didn't actually show you it running. And so it's a little bit slow, but this is running on an EC2 instance on our hosted cluster. And I really hope that returns.
You picked the small one. You the small one.
Oh, sorry.
Actually,
I don't know. Yeah, as if the demo weren't risky enough, we're gonna like integrate it into another platform. So that's all the functionality. I wanted to just give you guys a little bit of context of like where Scala Notebook sits in the overall notebook ecosystem. So obviously we are deeply indebted to IPython Notebook, and my understanding is they're either rebranding or doing a different thing called Jupyter now. This Spark Notebook ended up being I think he's coming to talk in March, so that'd be really cool to see. But I think Andy forked Scala Notebook and basically added a bunch of nice features to make it integrate with Spark more easily to do interactive type stuff. iScala was apparently a swappable backend for running Scala, but inside IPython Notebook. I think it was dead circa when we were doing this, so unless it's somehow magically revived, I don't know. I've watched a few demos, but I'm really looking forward to the Databricks cloud presentation, because they have a notebook type of thing that does specialize in this type of interactivity. So I'd love to see sort of the state of the art there. And 2 Sigma's Beaker notebook is in a very similar space with a big emphasis on language interop. And so I've seen some cool demos out of them. And yeah. So thanks, everybody. I'll be sticking around to answer any questions. We're hiring at Domino Data Labs. Scala Notebook is not sort of one of our core things. It's sort of just a thing we do for fun. But Domino itself is written all in Scala. We're always looking for talent. So if anything looked interesting here, we'd love to chat with you. And but you guys should also check out Scala Notebook. So this is the Bridgewater Scala Notebook GitHub project. And then I also made a public project on Domino that lets you sort of like try it out in one click. So this is public. You don't need to sign up or register or anything like that. So yeah, thanks a lot.